Let's take a look at the deadline QoS policy. The deadline QoS can be used to configure DDS to know how fast a data writer is expecting to send data or how fast a data reader is expecting to receive data. For proper operation, the data writer must send data at least as fast as the data reader is expecting to receive it. So DDS will actually actively monitor how fast the data reader is receiving data and or how fast the data writer is sending data to make sure that the deadline is being met. As soon as data is sent or received, a timer will be set according to the deadline. If the deadline expires before the next piece of data arrives, then there's a problem. In this case, we receive D2 within the deadline, so that's okay. Once another piece of data is sent or received, the deadline timer will be reset. In this case, we get D3 and D4. But let's say the data writer stops sending data for whatever reason. Once the deadline expires, there'll be a notification both to the writer and the reader. For the writer, it's telling the writer that, hey, you were supposed to send data within the deadline period, but you failed to send data. Or for the data reader, hey, we did not get data within the deadline period that you set. So this is a way for your applications to detect when there's a problem in the system. Of course, if you start receiving data again, then we'll still apply the deadline to make sure that you're getting the data again within the deadline that was set. So the deadline QoS policy is configured by what is known as a period. The period is a time. It's a time interval of which to send or receive data. So what does deadline period tell the DDS? Well, if you configure it for a data reader, it's basically how fast a data reader expects to receive data. When configured for a data writer, it's really telling the DDS how fast is the data writer going to send data. And then it's really up to the application logic to send the data. So setting deadline period doesn't automatically get DDS to send the data for you. You have to send the data yourself. So when setting deadline QoS, data readers must receive at least one new value of the data within that period. When set for data writers, the data writers must send at least one value within that period. If either of these periods on the writer or the reader are violated, applications will be notified. This is a changeable value, so you can change the period during runtime if you expect the time during the operation, the variation in how fast data is being sent or received. But this is also an RXO, basically request versus offered. The writer's period must be smaller than the reader's period. That is, the writer must be sending at least as fast as, but perhaps even faster than what the data reader expects. So if the data reader expects data once per second, it can set a value of 1 second. The data writer must send the data at least once per second, but it is allowed to send data faster than once per second. If the period of the data reader is less than the period of the data writer, this is a violation of the RXO. Let's take a closer look at when the deadline missed is being triggered. On the left-hand side, we have two lines representing an application and the data writer. On the right-hand side, we have a different application and its data reader. When the application sends data, it's going to call DDS data writer write, which causes the data writer to send data on the network, in this case calling send to perhaps on UDP. The data reader is receiving data by calling receive, and then when it gets data from the network, it will notify the application that, hey, you got new data, and the application can now get the data calling data reader read. So how are the deadline periods being used? Well, on the writer side, when the writer calls write, we'll set a deadline period. And if the writer doesn't call write again within that deadline period, we will let the application know, hey, you didn't write another piece of data within the time period you told us you were going to do, and we'll notify you that the deadline has been missed. On the reader side, Once it's received a piece of data, we'll set another deadline period. And if the data reader doesn't receive a new piece of data within the deadline period, we'll notify the application, hey, you were expecting data, but we didn't get it in time. Notice that the reader deadline period can be greater than or equal to the writer deadline period. So the writer can write faster, but cannot write slower than what the reader expects. So let's talk about the deadline QoS for the periodic streaming data use case. As we've seen, the deadline QoS is useful to detect when something unexpected happens. In this case, data is not arriving as expected. In a digital control system, this is quite useful. Digital control systems are basically receiving sensor values periodically and then calculating control that's sent out periodically. If a single sensor value fails to arrive, the digital control system could basically use older data to try to calculate what it thinks the best control is now. But it needs to know whether or not it's got a new value or the new value didn't arrive in time. So the deadline QoS can help with that. More generally, application failure can be detected using deadline QoS. Often, applications are sending out their health and status information periodically. And then if you stop receiving that information, that's a good indication that there's a problem in the system. Perhaps the application has crashed. So you can use the deadline QoS on a topic, where the topic is the I'm alive topic. And then when you stop receiving the I'm alive topic, then you can say, hey, there's a problem. However, you don't typically set the deadline QoS to be the exact period in which the health and status topic is being published. If your health and status topic is being published, let's say once per second, you don't want to set your deadline on data reader to be 1 second. If you do, then you'll run into the problem that just because you didn't receive one piece of data in time, you automatically will assume that the other side is dead, and that could be wrong. That's what is called a false positive. To avoid a false positive, you sort of want to give the other side a chance, maybe 2 or 3 chances, or maybe 3 or 4 chances, n chances of sending its data. So you'll wait for n periods in which you should have received n pieces of data. And if you didn't receive any of that, that's the time that you say, oh, the other application is dead. So typically, I would suggest at least 3 or higher. So if somebody's sending you an I'm alive packet once per second, I'll wait for 3 seconds. And if I don't receive an I'm alive packet for 3 seconds, then I'll trigger the logic, the process, assuming that the other application is dead.